Welcome. This is a brief tutorial showing how to deploy a Hugo static website to S3 using Terraform, and then using Terraform to create a CloudFront CDN distribution in front of that. So here we go. Assuming that you have Homebrew installed, you just want to install Terraform and Hugo using Homebrew. Install. Now we're just going to go to Circle CI and now add our project, our Git repository, which we've already got in Bitbucket to Circle CI. So we just select the project and we click that Start Building there, and that's going to start building our project. Next we find the Docker image that we're going to use to build the site itself, because Circle CI uses Docker images instead of explicitly installing software to perform its builds, at least since version 2. So we're just going to copy and paste the Circle CI config here, and just push that up, and that's going to start running. And I forgot that I just need to tweak the image version there, and the command, if we push that up now to Circle, to our repository, it's going to start a build, and we should be able to see it pulling the builder image we found, and yep, okay, it's all built and it's tested. Alright, so we have a green build. This is a great time to merge to master, so I create a pull request, do a quick review, looks good, so let's merge. Alright. So the next step is setting up the Terraform project. Now, usually you'd want this to live in its own repository, but because this is a very simple project, we're not going to do that. We're just going to create a directory underneath our main project called Terraform. I'm going to create a main.tf and a providers.tf. So providers.tf is where we're going to enter the provider libraries that we're going to be using. And then we're going to create a backend.tf, and if you check the Terraform documentation, you should see an example configuration for storing your remote state in S3. So you just set up a bucket, a region, and a key, which is the file name. And what that's going to do is that's going to store your Terraform state remotely so that it's doesn't get out of sync. So let's create the bucket that this is actually going to store into. So we need to do this manually, but all other infrastructure is going to be controlled by Terraform. But this is simply setting up. Now when you're creating this bucket, make sure you click versioning. So this allows you to roll back to different versions of state. And it's always a good idea to encrypt this bucket so that your Terraform credentials are encrypted at rest, just for security. So that all looks good, so we're going to create that bucket. And we can see it here. Okay. So the next thing we want to do is we want to create the user that the IAM user that Terraform is going to use to authenticate with AWS and to perform its commands. So we just want to give it administrator access and set it up as an IAM user. And you should see the access key here. So you want to go into your AWS credentials file and just copy that. So I won't show you actually the credentials, but once they're in, you can go into the Terraform folder and run Terraform init. That's going to initialize the backend. Now what we do is we create an s3 bucket.tf file under our Terraform directory, and just add an AWS S3 bucket resource. So we want to give that some tags. so it's identifiable in the console. We specify the bucket name, the ACL, which is access control, which is going to be public read, so that it's publicly accessible. And then we add a website block, and the website block tells Terraform to set this bucket up as a static website, and we just define our default index and error files there. So let's deploy that. So once the bucket has been provisioned, we can test it out locally with our local Terraform credentials and just see that we can sync with the bucket, and that should upload fine. Now we want to set up a publish workflow in the Circle CI configuration. So I'll just copy an example from another project and paste it into my configuration file. So essentially we've got two jobs, build and deployment, and then we set up a workflow which then chains them together. Make a few tweaks, just rename the test job to build and make those required changes. Okay, now we want to remove the deployment because we're not using Heroku in this instance, we're using AWS. So what we want to do is persist to workspace as a step of the build, and then attach workspace as the first step of the deployment. So what that does essentially is copy the artifacts from the first job into the second, because they are going to be running in completely separate images. So once we've attached to the workspace, so that's essentially copying the files from the previous image across, we then need to push them up, and I've actually ended up making a mistake here. The best way to do this, I found eventually, was to instead of using the Node.js image, use the Python image, because AWS is a pip package, pip being the Python package manager. So what I ended up needing to do was changing to the Python Docker image provided by Circle, and then you can see me debugging this. Yeah, there we go. So we changed to Python, and then before we push, we actually install the CLI, the Amazon CLI. Now we need to install with -- user because we don't have permissions. So now what we want to do is, now that we're running that publish command, we want to set up a user account for Circle to be able to upload without giving them access to the rest of our infrastructure. So we want to create an IAM user just for Circle and create this policy here which gives Circle, the Circle user, the ability to publish to our S3 bucket and manage our S3 bucket, but that's the only permissions they're given, as opposed to the Terraform user who has full administrator access. So we just apply that and set up the Circle CI user. Now I'm going to add environment variables to the Circle CI project, which are the access key ID and secret access key generated by Terraform from that user. And these are going to be injected into our script. Now the next step is to create a AWS CloudFront distribution resource in the Terraform project. Now that is going to point to our bucket, and I've just basically copied and pasted the example from the Terraform documentation, and specific attributes here are not too important, we'll go over those later, but the most important part here is that our origin is pointing to our AWS bucket website endpoint, and that means that CloudFront is going to sort of act as a proxy sitting in front of the static website provided by S3. And so CloudFront is a CDN which allows us to have much faster download speeds globally than S3 would normally be able to provide. So it's basically like a caching layer for an S3 website. So once we have that deployed, we then set up some AWS Route 53 resources. So we start with a zone, which is going to be our a set of name servers attached to devbrett.com, our primary domain name, and then we create two records. We create the bare record and then the www record. So now I'm just going to go to my GoDaddy account, which controls that domain, and find the zone that we created earlier and find the name servers. So there should be 4 there. We're only going to need 2. So if we go down to the name servers, we can switch from the default to custom and then enter 2 of the name servers that AWS provide us in Route 53. So now that means that any DNS queries to this domain are going to circumvent GoDaddy's servers and go directly to AWS. Now, before we move on, I just want to open the bucket that we created and open the static website link just to verify that our S3 bucket and static website is set up correctly. So it is, but we seem to have some issues with our SSL certificate. So what we're going to do is we're going to find here under viewer certificate arguments a attribute called ACM certificate ARM. Now this allows us to link an AWS managed SSL certificate to our CloudFront distribution. So we don't have that just yet, but let's just put it in here under viewer certificate anyway. We'll just leave it blank for now. And now what we need to do is we need to create a data resource. So a AWS ACM certificate data resource is going to search our account for a certificate that exists in our the region that we want and matches the domain. The reason why we can't just create the certificate through Terraform is that it has a human verification process, and so it cannot be fully automated at the moment. So then what we do is we point the CloudFront distribution certificate to the one we found using our data resource. So that's going to search for any certificate that's the most recent certificate issued. Now let's actually manually create the certificate. So we need to make sure we're in the US East 1 region because that's the one that CloudFront operates in. And let's request a public certificate. So we just enter our root domain name here, devbrett.com, and now we add another one and we do star.devbrett.com. So that allows us with this certificate to support any subdomains. And we'll choose DNS validation, it's the simplest. And you can see we have started a request. And in order to verify it, you need to add this record to your Route 53 zone. But there is actually a way, a button which adds it automatically. So if you go back to the certificate manager, open up that domain, and there's a create record in Route 53 button. So that will just create it for you, which saves a whole lot of messing about. Now, you usually have to wait about 10 minutes for that verification to go through. But we can see here that the verification entry was added automatically for us in our zone. So after a few minutes, what will happen is this pending validation certificate will become issued, roughly 10 minutes. At this point, we can detect the certificate with CloudFront. Now, the one issue we're having here is that because CloudFront operates in a different region than our bucket, we need to set up multiple region providers in Terraform. So we do this by explicitly setting our provider aws.global. So this is going to look for a provider in our providers file with the alias of global. So let's just set that up now. So our default AWS provider is going to be EU West 2, which is London. But if we create this new one with an alias of global and set it to US East 1, now we can use this for provisioning CloudFront and for searching our new certificate, because our certificate that we just requested doesn't exist in London, it exists in the US East 1 region only. And that's the region that CloudFront is going to look for when it sets up its certificates. So now let's go back to our Circle CI project, and I've just rebuilt it with SSH so that I can SSH into the container, and it seems that the AWS CLI is not installing correctly with pip, and I believe this is because we're using the --user argument when we install, so it's actually installing to .local/bin. So what I realize I've got to do is I've actually got to add this .local bin directory to my path so that when I call the AWS executable, it's going to find it correctly. So I just test this from within the container and it seems to work. So I'm going to go back to my Circle CI configuration and just add in those steps. So after I install the CLI, here I just want to export the path variable with the local bin directory prepended to it. And so that means that when I don't need to do anything fancy, AWS is going to be available on the path, and that should work. So let's just commit all this and push it up to our repository. Okay. So the act of pushing this is going to trigger our pipeline, and if we view it here in Circle, we should see the build running successfully. Okay, and now the deployment looks like it has succeeded as well. So that path change seems to have worked. Okay, so now let's test the CloudFront distribution. So if we go to the CloudFront and get the domain name, we can now see that CloudFront is successfully linking to our bucket. However, it does look like there are issues with the CSS resources and some paths, so we'll fix those later. At this stage, it's just good to realize that CloudFront is talking to S3 correctly. Now, if we go to our domain, through HTTPS, we'll realize that we get this error SSL version mismatch. So this is because if you check out the CloudFront origin, the CloudFront settings, distribution settings, we don't have any alternative domain names set up. So by default, CloudFront is only going to provide a certificate for cloudfront.net. So here we're going to need to update our CloudFront distribution resource with the domain names that we want to serve it from. So if you check the documentation, you should be able to find here that there's an attribute called aliases. So we just need to add that to the resource and add the domains that we need there. So if we add those and deploy, all right. So now we need to just test the SSL certificate and make sure that that matches, and it looks like yes, that's fine. We still have the issues. Now there's one thing I notice here is that I accidentally added a geographic restriction, which meant that only US and British users could access the CloudFront. So I just removed that now. We don't need any restriction. I think that was just copied across from an example. Now let's have a look at the CSS relative paths. So I've just made a few mistakes here in my templates. And if I test that now, it looks like those resources are displaying correctly. Now we're just going to make a few tweaks to the CloudFront configuration. And now this is mainly to do with URL management. We're going to redirect HTTP to HTTPS, and we're going to compress. And we're also going to add a custom origin config, which allows us to use the website endpoint instead of the S3 domain, which just simply allows CloudFront to delegate to S3 to do some URL rewriting. Now, if you see here, some of our URLs are broken, and that's because S3 isn't very smart about URL rewriting. An easy fix for this is simply to look at the Hugo configuration and enable ugly URLs. So essentially adding .html to the end of our links. So I'm just going to go through my templates, and I see that I'm missing a project page. So I need to, if I look in the content, nothing's getting generated, and I think that's because all my projects are drafts at the moment. So I'm going to add an index file here. I'm just going to copy it across from the portfolio section and add in a projects index file. Okay, and just make sure that that's not a draft. If I rebuild, that seems okay. So it's generating an XML index as well as a projects file. But yeah, there's no projects, so I need to add at least one. Anyway, let's just push that up. Okay, so at least the projects page should work. Okay, that's gone through the build pipeline, and now I should get an, oops. So that still hasn't updated because the CloudFront cache is behind a little bit. It can take some time, but if I verify by going through the S3 bucket, I can see that those have updated. So now there's just a few more links here in the home page that need to be updated. So I'm just going to see if I add .html to those URLs, then they will be found correctly. by S3. So I'm just going to run through all those templates and update them all. Okay. It's quite a few. Okay, this is all a manual template that I've written out. So, okay, so now if I look at my local build of this, I should be able to see everything working correctly. Oops, no, I need to enable the ugly URLs in the config. So ugly URLs true in my config.yaml, restart that Hugo server, and now everything is set up. I've still got that empty projects page, but now all the tags seem to be working. Just need to update that final tags link there. Okay, so that's all connected, and those all seem to be working. Okay, so let's commit that, push that up, and that should deploy automatically. And now before I commit the Terraform project, I'm just going to add some git ignores. So we don't want the Terraform temp file, which is where we write out the credentials. We don't want the Terraform tf state file or the .terraform directory. Okay, now let's fix that empty project section. I believe it's because all the articles here are drafts. So if I go here and I just undraft one, publish one, so say false, and I'm just going to get rid of that lorem ipsum text, get it from my GitHub page, copy paste. Okay, so at least I've got one project in there, so it's not empty. Alright, so this seems good enough. Obviously needs a bit of love, but let's just prepare our feature branch for the merge now. So we no longer have to deploy on every branch. We only really want to deploy on master. So let's commit that and push that up. And create a pull request. And so I always make a point of reviewing my own pull requests even when I'm working on a personal project. So it seems like we've got some merge conflicts. So I'm just going to do a git rebase. I'm going to pull, switch to master, pull the latest changes, switch back to my feature branch, and now do an interactive rebase over master. Okay, now there's a few conflicts, so I'm just going to update that and get rid of those conflicts. Okay, and I'm going to, I just need to add that. Okay, now I can rebase continue. That's fine. And continue. Cool. So I'm now rebased. I should be able to force push my feature branch. And if I go back to the pull request, all those conflicts should be gone. Yep. So let's just do another quick review. I think I can fix that couple of things in those scripts, just tidy those up a little bit. Yep. A couple of white space issues, just a few little tidies. No, that's all looking good. I disabled this backend because I had issues on and off. I think S3 was having some troubles. So if I re-enable the backend, I did this off screen, sorry. Just tweak this Terraform script. It's not really important. So if I Terraform init, that's going to initialize the remote backend. I can just confirm here, yes. And it's going to reinitialize. Okay. and if I actually run, it's got this weird error, send request failed to S3. So this was the issue I was having before. So I did some research and I found this GitHub issue here, and if you skip credentials validation, this allows you to continue. So I reinitialize and I run deploy and everything's good. So now I'm storing my Terraform state on S3 again, which is best practice, especially if you have more than one user working on a Terraform project. So I'm just going to update that and commit that and add to our pull request. Okay, and there's a few other changes, tweaking those helper scripts. And just amend this. Some minor white space change. Alright, so I'm pretty happy with that. Let's push this up and do a final review, and that all looks good. Yep, happy with that. Right, let's merge. It's past our CI. Now if we check, because we merged to master, it will deploy, and let's check the website. Yep, all those links seem to be working. Our new project's there. And yeah, it looks like most of the content is working. So that seems to be it. Hope that gave you a good overview of how it all works. It can be a little bit tricky to set up, but yeah, having a cool CI pipeline and deploying in this way keeps costs low and certainly makes things more agile when you're developing static websites. So yeah, if you have any questions, please put them in the comments and let me know. Thank you very much.